Yeah, we've shared our screen. You should be able to see our screen now. So welcome everybody to our webinar on 5 shocking results from the hidden internet from 12 months of monitoring. Today we have the researcher with us. Our speaker is Jitendra Chauhan. He's the head of engineering at FireCompass. He has 13 plus years of experience in building products, R&D, and cybersecurity. He's a graduate and postgraduate from the IITKharagpur. He's currently heading engineering at FireCompass, Bangalore. His core expertise includes web and network penetration testing, secure source code auditing, building research tools, and J2EE security training. His interests include machine learning and its application, cybersecurity, microservices. He has worked on many exciting products, including multi-vector analysis, building a SaaS platform for VAPT, SIEM, and building testers Workbench for conducting business logic testing. He has also conducted penetration testing and secure source code review for major industry verticals, including banking and life insurance, e-commerce, casino, GRC, etc. If you have any questions for the speaker, kindly drop it in the questions box on the right hand side. You will see there's a questions box, and we'll be taking the questions at the end of the session. Apart from that, we will have some short surveys in between, for which we'll share the links, and you can see the live results for those. Thank you, Jitendra, for joining us today. Over to you.
Yeah. Hello, everyone. Good afternoon. So let's start. So today's topic is 5 shocking results from the hidden internet, and that we have we have gathered the insights from our last 12 months of monitoring the deep and dark internet. So I think most of you know that for the last few years, especially last year and so, some of the major hacks has happened in various industry category, and some of the reasons were like shadow IT, like someone has kept MongoDB opened for hackers, and then they went and grab the data from MongoDB. Similarly, someone has kept Elasticsearch open for hackers. Then open S3 buckets, like in one of the case, open S3 buckets had the customer data open for public. Right. So shadow IT was one of the major reason for hacks last year. Now, few months, I think 1 month back or so, you might have heard that in the dark web, terabytes of leaked credentials data has leaked, not leaked, but got into the public internet, and that was the set 1 data. So we have got hold of that data, and also after that, I think some of it is not less, it is less known that after that 2 more data sets came, which contains more than the number of passwords that was there in data set 1, right? I think many of you know that leak credentials, attack vectors such as credential stuffing, where the attackers reuse the password, try the password which the employees might have used on other websites, which might have hacked on some of the corporate websites, and then might get hold of accounts and employee accounts, and that may lead to further advanced attacks on your organizations. So this was another major cause, and some of the names are surfaced here, where leak credentials was one of the attack vector used by hackers to compromise the organization or some part of organization. And then finally, third-party risk or third-party vendor risk is another attack vector, another threat, which is there. And some of the names which are highlighted here are part of these attacks, have been part of these attacks. So some of the examples where third-party vendor risks have surface include, when the developer include third-party JavaScripts which are not so secure, not well tested into your web application, and that may lead to your web some form of compromise of your web applications, where attacker can do attacks such as XSS and then some form of phishing attacks. Similarly, we have seen and there has been a lot of instances where the data that is shared with a third party are left exposed publicly online. And there has been various instances where our company, FireCompass, have intimated even some of the banks that their data was there on some of the MongoDB or Elasticsearch servers, unauthenticated by some of their vendors, right? So this has happened. Similarly, some of the instances, we have seen, and also, you can read in the major hacks that third-party vendors have exposed some of their staging servers or UAT servers, where they have exposed the production-like data on staging servers, which includes even the sensitive information and PIIs exposed. So this, so there has been various instances of this attack vector too, right? So in short, for the last years, some of if you look at the top 20 attacks that have happened, majority of in a lot of places, some of the reasons were actually these three: shadow IT, decredentials, and third-party risk. So the question that we asked ourselves, as a team, at FireCompass, that are these are these only few instances of hacks, or the problem is more deeper or intense, right? So we had like three questions to ask. What else is exposed on deep and dark internet apart from just MongoDB or Elasticsearch or some of the leak credentials? Do we have more that can become part of the attack? How many such resources are exposed online? Like, what is the number? Is it like few hundreds, few thousands, or even much more than that? And how critical are those resources, right? So to answer these questions, what we did is we set up an experiment from our technology team and as a whole FireCompass, where we index the deep, dark, and surface web, right? So I think dark and surface web, everyone knows. So the deep web we define is something where which is not that visible on any of the search engines. So you have to look further using various kind of docs to extract the information, right? So we index deep, dark, and surface web, and we wanted to, as a technology, we wanted to have few goals, right? So we wanted to monitor the whole internet, monitoring the internet, deep and dark web, to collect insecure services, sensitive data, and leak credentials. Okay. After we index and store this data, we wanted to sample some of the exposed data and perform how sensitive these services or these data is. And if we find that something is actually sensitive, such as exposed PIIs or some MongoDB with exposed customer-related data or something like that, we wanted to generate an alert to our team, right? And when we get an alert, we also do real-time attribution of that sensitive data to respective organizations. So like this sensitive service or data which is exposed, to which organization does it belong to? So we had these three goals. With these three goals in mind, we set up a big infrastructure Now this is a small glimpse of the setup that we have. Before I show you the insights, I just want to tell you that how our setup looks like. So as you can see that we have we collected millions of domains and billions of subdomains, right, from various data sources, mostly passive data sources. Like we have not scanned actively any of the network to do this. Mostly it is passive collection of data, subdomains, right? Once we collect subdomains, we also get to know the IP addresses from various DNS, passive DNS, A records and AAA records. And once we get the IPs, we get to know the ports, the services which is open on those IPs. And then we try to correlate those services and try to correlate that with the domain and subdomains, and then finally with the respective organization. We have been monitoring various dark web forums and various onion network sites and insights. We have been monitoring paste sites for various paste, right? Now, as you know that paste sites are the sources of sharing information, say between developers or between two vendors, for example. And many times, sensitive information can be shared on paste sites. So we go and monitor that. And many times, hackers use these paste sites to disclose sensitive information, like the last leak credentials were actually exposed using some of the paste sites. The links were exposed using some of the paste sites. So we go and monitor them to see any sensitive information. We also monitor various source code repositories like GitHub or Bitbucket, open repositories, which are GitHub and Bitbucket and GitLab. And then we try to attribute them. We do sensitivity analysis of the code and try to attribute them to respective entities, user entities, and then possibly to organizations. I mean, sometimes it is not that obvious to do it, but yeah, we try to do it. We have also indexed terabytes of leak credentials. Currently the size is around 7 billion, which includes plain text passwords, some of the hashes in MD5 or SHA-1 or SHA-2, and some of them are also solid-state passwords from various hacks that has happened in the past, like LinkedIn, for example, right, Zomato, and so on. And then we also have been indexing buckets from various cloud platforms like S3. Most common is S3, but then Google Cloud and Azure and DigitalOcean also have similar buckets, and which are left open, mostly for non-sensitive data, but sometimes the sensitive data can also be exposed using these buckets. Then we go and index this data in a storage where we have indexed like petabytes of data. Currently we have, and then we do analysis and attribution using some form of machine learning, and then we do generate some reports, right? So this is the setup that we have used to collect and index data and generate some insights. Now, after we've done this, let me show you some of the insights, which is pretty interesting. Okay, so many of you know that for the last few months, there has been many hacks. There have been many hacks because of exposed databases like MongoDB and Elasticsearch. But then the question is, how many of them are exposed online? And apart from the MongoDB and Elasticsearch, what else? What are the other databases exposed? Now, when we look at the data, the results are pretty shocking. So this is some of the statistics that we gathered, and I want to share with everyone. So overall, not just few hundreds, but then 500K databases, popular databases are being exposed online worldwide. And this is a pretty shocking number, because databases are as per various compliance regulations and requirements, the databases are supposed to be hidden behind the DMZ and internal network, and only should be accessible to the connecting web applications or other applications. But then these databases, probably because of the cloud adoption, these databases are kept online, public, and many of them are without password. Yes, without password. Right. MySQL is at the top. Probably is like 60% of the number is just MySQL. But then MongoDB, Elasticsearch, and Redis, are not far behind. The size of sample data which we have collected from some of the public databases, without crawling anything, is more than 20 terabytes, and this is just a very conservative figure, of course. Right. And in India itself, the number of databases open are 5,000, right? 5,000, which include MongoDBs, Elasticsearch, Cassandra, Redis, and so on. So as everyone say, data is the next gold mine, right? And then this gold mine is exposed publicly. So yes. And another interesting statistic that we have observed is not that the databases are exposed online, but also every day the database number is changing. Like many times the database come and go, and this may be because many times the team perform a test, say on QA database or on staging database, and when they need it, they expose it online, and then they disable it maybe after a few days. So this number changes every day. So everyday monitoring. So we conduct everyday monitoring, and this number keeps on changing every day. So every day we have found various databases publicly exposed. Now, from our experience itself, from the major hacks that everyone knows, from our experience itself, we have a couple of interesting. I want to share some of the interesting examples. Like in one of the example, we found out that one of the major bank from India, one of their vendor, probably a machine learning vendor, AI vendor, was exposing their customer transactional data online on a MongoDB server, right? When we found out that, we immediately, notified the bank and told them that respective, IP, etc., which was exposing the data, and the bank could, find out which vendor it is, and they could have, they went and, and disabled the database port, for example, right? In one of the case, and there have been similar other instances, where we have done it. In case of MongoDB and Elasticsearch, databases open. Now, in another instance, one of the case that we have observed is for one of the customer who are actually is a SaaS provider. They exposed one of their staging MS SQL database online. And this SaaS provider was providing various services, was providing a SaaS application to various, even to various banks, right? And we immediately found out and attributed this to the vendor, and then we identified the vendor and notified them. Immediately they were acted upon it, and they could actually disable the respective firewalls, right? Now the question is that how long should we wait for companies like us to notify that certain data is open? Actually, we can do it proactively using very proactive monitoring to find out the infrastructure which is being exposed online. So I have a survey form. I have a survey to all of you. Preeta, can you share the link? And the question is very simple: that how often do you monitor your online digital infrastructure exposed, especially for critical services like databases or maybe LDAP or maybe message queues, etc. Is it like frequently, less frequently? No, we don't do it, or it's like very ad hoc way, or we don't do it at all. So we have a small survey. Please go and fill this up. Preeta is going to share the link. And I think we will take, we'll take 1 minute to where you can even send me a question, and I'll try to answer. And in the meantime, please go and fill this survey, and we will take 1 minute break to get the answer so that you can keep focus and provide the survey. Okay. Preeta, have you done it? Yeah. Okay. Okay. So once everyone fills up, we can actually go and even show you some of the results, right? So this is so. So this is the live results.
We just started.
Yep. So it's pretty interesting that majority of the cases it's not daily, which should be the case because databases are, as I said, databases are gold mine. Yeah. So it seems that quarterly, like once in 3 months, is winning at this point, and which is, I think, probably because of the compliance reasons. I'm sure about, right? And even the annually is like not that far behind. Yep. So it's interesting. Yep. Okay. All right. Thank you very much for filling the form. We will continue with our webinar. Do you have any questions anyone has sent? Okay. So we will answer the questions at the end of the webinar. So let's continue with our next topic, which is leak credentials. Right. This is one of the favorite because passwords are everywhere. Right. So as I mentioned before, we have like around 7 billion entries, password entries from around the world. Of all or majority of the leaked databases we have collected so far, and it was like 6.7 in Jan. Now it has increased to 7, right? And what we have observed from our experience, and not just for the last few years, but from the days when we started working in security, that majority of organizations, of significant size, the employees, most of them are reusing the passwords. The employees are reusing the passwords, and then they change the password to in a way so that it is very predictable in a certain pattern if a strong password policy is enforced, for example. And then we have noticed that 40% of organization of certain size, of certain size, could be breached just using leak passwords. In some of the cases, I'll give you one example of one of the few of the cases that we have even observed, that in one of the for one of the organization, what we observed that some of their employees reuse the same password online on, say, third-party sites, etc., and those sites got leaked and breached, and then definitely we have those passwords. So what we did is we tried those passwords on some of their systems, with their permission, of course, and then we found out that some of their employees' passwords actually are strong, but then are leaked and they are reused even internally. So what we could have done, we could have used those passwords and as you know, and then we could log into their email web application, HRMS web applications, and then from there we could use the single sign-on feature to log into other corporate websites, and we had everything like from those small fewer number of passwords which were leaked. So this is one of the example, and there are many such instances. We have seen that even the one leaked password hit, if we use, it can compromise. It is good enough to compromise an organization as a good starting point, at least. Right. And we have also found that for every organization, major organization, we also found that from this leak credentials, we could even discover 5+ common password patterns. Like every organization has a pattern, right? org1 @123, so on, right? So this is one example I'm giving you. But then there are various patterns which are reused by internal employees to set their password. So what we found out is 5+ common password patterns for every major organizations from whatever study we have done, which is pretty interesting. Now, from this data, which is like terabytes of data, we actually found very interesting thing. Like everyone knows the weak password, right? The password which does not satisfy a strong password policy of an organization, right? But then there are also common strong passwords, which means the passwords which satisfy your organization security policy and have alphanumeric uppercase letters, lowercase letters, but actually are strong passwords, but actually are common. Common means they're reused by various people, various employees. Then there are also common super strong password, which means these passwords actually are satisfy the whole accounts policy, password policy, which have like special characters, uppercase, lowercase, etc., but actually can be guessed and can be broken or can be found out from leaked database very easily because they are being reused at various places, right? And these are the very important distinction we should have, that even if we have a strong password policy, it's possible that the passwords are not really very strong because they are being generated using a pattern which is very predictable. So everyone knows the password. It was very common in the past, but not that uncommon today too. So these are the various password variations that we could pull out from the database. And as you can see that these passwords, variation of this password are being reused so many number of times. Like this first one is used like 42,694 times in our database. Various users. Similarly, the next other password variations. Now this will become important because various while reviewing the password policy, some of these passwords can resurface in your organization. So these are the example of common weak passwords. I will give you some examples of common strong passwords which have uppercase and lowercase and numeric, and they actually are strong, but then they are being reused using so many times. Like this password, which looks very strong, but then is being found at 1,21,000 times in our database, which means it's a pattern, certain pattern. And by the way, this whole password list is global. So for Indian context, you may not find it a pattern, but then globally, if you look at it from various countries, and this is definitely one of the pattern we have. Similarly, this password, if you look at it, it's 3RJ, 3RJ S1A, right? So this is a specific, keyboard pattern. Now, many of them actually are specific keyboard patterns that people are using to generate a lookingly, a strong password, right? So this is very interesting, and we have noticed from our penetration testing results that various such passwords are being generated in various organizations, like very specific pattern. The keyboards patterns are being used to generate passwords by internal users. Similarly, there are passwords which are super strong passwords, but are common super strong passwords, which are looks very strong, super strong, but then they are actually reused by various places because right. If you can see, the first one is actually is super strong, but then it's being used like 16,703 times. Has been found so many times in our database, which means that it is possible to generate it very commonly. Similarly, the next password, if you look at it, is just like 1QAZ, then exclamation QAZ. So it's like 1QA. If you look at the keyboard, then it is small letter 1QAZ, and then you press shift, and then again you repeat 1QAZ. So this is again a strong password which is generated, which has all the special characters of, which has a special character, uppercase, lowercase, number, but has been generated using a specific keyboard pattern. And this looks strong, but actually, unfortunately, it is not. Right. Similarly, there are many such password instances. You can look at it, which can be reused in the organizations, satisfy the strong password policy, but actually are not secure because attacker can use certain dictionary attack based on these common passwords and then can crack them, right? So now after this topic, we'll again send you a link for next question, a survey link for next question. And so we wanted to know whether how often do you check common password or common strong password or common super strong password? How often do you check it? So Deepa, can you share the link?
Sure.
Yeah, and I think we'll wait for one minute, a short break so that participant can fill up the answers. Okay, so she is just going to send you the link. Okay, I think you might have received the link. Please go and just quickly answer so that we get to know everyone, the community, everyone get to know, what's the state. So one of the questions that someone asked is if a password is salted plus hashed before storage, the list shown won't be available to steal. Yes, this is correct. If salting and hashing is done correctly, but we have to be aware that it is done actually correctly, so it has to be security reviewed. Because we have seen some specific cases where this was not done in a proper standard way, and because of that, there is a possibility that the passwords salted hash password can still be retrieved using rainbow tables. Okay, I'll just show you the results of the second survey quickly. Let me see what we've got. Yeah, so very interestingly, majority of the organizations have either no visibility or possibly do not know. I mean, that's like no visibility, or so only 14% of the organization at this point, looks like have some form of visibility on these three passwords, kind of passwords, and it shows that yeah, it's really an issue. And okay. So should we go to the next topic? Yeah. Okay. All right, from the land of passwords, we'll go to code leaks and CI/CD. The reason we want to do this is because there's no reason for an attacker to conduct APT style attacks on your production environment, which is more secure, have better firewalls, tools, probably most of the time. And right, if they can actually get those API keys, credentials from code leaks, code which is possibly can be exposed on public repository, or from a CI/CD server which is kept open, and then they can go and either steal the get the build, extract the data from the build, and in the data possibly there can be some form of keys which can give them access to production servers, or even in worst case they can even inject instrument the code, the build, and then again upload it to the CI/CD server. So the victim organization can possibly go and run their code, run the instrumented code with possibly malware on their production server. Yeah, right. So this is very important. So what we did is we went and found, we went and crawled, some of the code public code repositories which are exposed online using GitHub or Bitbucket or GitLab and few others. And then we found out, we ran sensitivity analysis tools on it to find out if there are any keys, mail server, keys, passwords, or any form of sensitive information available online. So from our sample, we figured out, we found out that a staggering result of 20K plus keys, from various GitHub sources, after removing some of the false positives, which looks obvious, like test data, or data which looks for examples or documentation. Which is pretty large, and although we are not able to attribute each one of the keys to respective organizations, but that we will be doing in the next few months. But then, yeah, this number is quite staggering. Now, what we have also observed that 50% of the cases in every organization of certain size, significant size, the employees have published in one time or other time code on GitHub or on other public code repositories, where knowingly, unknowingly, actually they have published credentials, keys, and sensitive information along with it, such as private keys, even the AD passwords we have noticed many times, mail servers, passwords, because the configurations are when you write a code, you have configurations, and then they put the configurations, the keys and passwords inside the configuration, and they forget to ignore it in say JIT, and then they publish it. In some cases, we have also seen, few employees, for certain organizations, we have also seen that they submit their pay slips on GitHub, and also the internal product screenshots, etc., on GitHub, which is pretty interesting. So this is another interesting stats. And also on CI/CD tools, such as Jenkins. So what we did is we conducted, we collected, what all CI/CD tools which are exposed online, And some of the stats are pretty interesting and also worrisome. Like etcd, which is a key value store used to store sensitive information and is used in Kubernetes. Kubernetes is basically, everyone is aware that it's a Docker container engine to run Docker and run and manage Docker. And this Kubernetes use etcd to store sensitive information such as private keys, credentials, and secret keys, so that can be shared between multiple Docker instances, right? Now, this is very important that many times we have seen 2480, we have seen around 2480 etcd open without any password online, and we could extract around 15k private keys and credentials from those etcd, although we have not attributed them to real organizations yet, but then this figure can be really worrisome. And this has happened because probably organizations have set up their custom Kubernetes cluster, and they might have forgot to block etcd. They might have forgot to firewall etcd because they may think it's not that important or so. I don't know. Similarly, we have seen, Docker, there are 939 Docker registries which are exposed online. 939. Some of them are actually with no passwords or weak passwords. Similarly, Artifactory, which is used to deploy or host jars and build artifacts that are finally, get pushed to the production servers using various tools such as Jenkins or GoCD, is also exposed with the default passwords. Some of them are default passwords and are exposed online. And finally, one of the major CI/CD tool called Jenkins, which everyone aware, and unfortunately, from historical reasons, it had no default passwords unless someone go and set it up. It was also, there were 2,614 instances exposed online. Many of them had no passwords. And with that, what you could do, what attacker can do is very easy, download the builds, get the sensitive information in it, and get and some of the sensitive keys and private keys and credentials can belong to the production servers. So yep, this is also interesting figure. And okay, now so we have after this we'll go to open cloud resources, right? Now everyone is aware that S3 buckets have been major cause for breaches in the past. Even Amazon and various organizations have kept S3 buckets open with sensitive information. But then we wanted to know, apart from S3 bucket, what are the other cloud resources being exposed online, right? Okay. And some of the stats are pretty interesting. Like what we figured out is from the data that we have, around 10K plus public EBS snapshots from 3,000 plus accounts were exposed online. As you see that, EBS are hard disks for the cloud resource environments, right? So these hard disks get snapshotted, and then for some reasons those snapshots are kept in public, maybe for downloading to internal network, and you can see that if attacker can get hold of these snapshots, they get the whole data which is stored on the EBS volume, right? So this is pretty worrisome, right? So I think one of the action item is for everyone here is to go back and check to do a kind of audit, like what all cloud resources being exposed online, if there is any, right? And some of them are definitely EBS snapshots. In other statistics, we have observed that 400 plus RDS snapshot, which is a relation database in Amazon being exposed online from 200 plus accounts, like right, and as you can see that RDS snapshots are as good as the data RDS MySQL, access to MySQL or RDS itself, right? Similarly, 700K Amazon AMIs from 20K accounts has been exposed online. Now, what is AMI? What we need to do with AMI at all? AMI, as everyone can see, that these are the public images of OS, right? That you can use to boot up a system. Now, if these AMIs are custom and prepared by an organization, most likely those AMIs can even host certain sensitive information such as private keys or credentials left behind while preparing the AMI, because those are supposed to be custom, right? And if attackers get hold of these AMI images, they can boot it up on a machine, and then they can do some analysis to find out if there are any private keys and so on, like SSH keys or private credentials, configuration files, etc. And they can then go and try out those on production environments, right? So this is another pretty interesting thing. Another interesting statistics that we had is that 17% of AWS managed Elastic servers were public IPs were misconfigured, right? At that, at some point of time, which means they had weak credentials or no credentials at all, and attackers can go and access either the Elastic server or Kibana, and they could access actually the data. And many times what happens is we have seen that so there is a Kibana and there is Elasticsearch server, and when someone configure authentication, they forget to they basically put an authentication on top of Kibana, but they forget to firewall the Elasticsearch server. And then all the Kibana is protected by a password, but the Elasticsearch server is probably unauthenticated, and attacker can go and get data from there. Similarly, we have found, we have millions of 500 millions of buckets indexed with terabytes of data, although the analysis is not yet complete. But then, some of the, we have seen in the past, for some of our so some of the customers and some of the, some of the prospective customers, for example, that where we have notified them of publicly open S3 bucket, which hosts actually either the customer reports or their own sensitive information not supposed to be shared publicly. So yeah, these statistics are pretty scary, and this shows that although our focus is just S3 buckets, for example, but there can be a lot of other resources, cloud resources, which can be exposed online, and we should have a mechanism to track those. Right. So before we go to the next topic, we will share one more survey. I think this is the last. Preeta will share the link. Please go and fill up the link. Preeta, can you share the link?
Sure.
Yep. Right. So the question here is, do you continuously monitor your online code repository? I think yes, no, maybe. Let's go and fill it up. We'll take 1 minute break so that we can fill this up. So CI/CD, when I say, one of the questions I want to ask is, what is CI/CD? CI/CD is continuous integration and continuous deployment. I didn't explicitly mention there, but then yeah, this is what we meant. Okay, so I think one of the question is, please give some examples of shadow IT risk. Now, shadow IT is pretty well known right now, but just to give, just to explain it very quickly, it is either an asset like a server or application, or maybe a domain, subdomain, or any other asset which belongs to an organization, which can be attributed to the organization, but actually is kept in public domain or public internet with or without authentication, right? So some of and that actually can pose a risk to a threat to the organization. Now, some of the examples are like, I think in the beginning I've given an example where for one of the organization, the MongoDB was kept open without authentication, and how hacker have found it out. One of the hacker has analyzed the mobile applications of the organization, and then he figured out that the mobile applications actually is making a call to one of the server, right? And then when he did the small port scan on some of the well-known ports, he figured out that there is a MongoDB running on it. And then he figured out that this MongoDB is without password and actually hosting a customer database, right? So this MongoDB with having a MongoDB is not a shadow IT, but then having a MongoDB publicly exposed and without authentication is example of shadow IT risk. Similarly, S3 buckets, open S3 buckets. The S3 buckets, which have a sensitive information when kept online, open, and the organization doesn't know that their policy, or as per their policy, this bucket should not be open because it is having customer data, for example, is another example of shadow IT. Similarly, having your any servers which are supposed to be like having a staging server without authentication online is another example of shadow IT. So these are some of the examples. Now we will go to the results, some of the survey results. We're still waiting for results, but then some of them looks like this. So around 62% says no, which is pretty large number. And then 25% says maybe. So yeah, so this shows that the code repository is not yet monitored that frequently, but then it is one of the cause of unknowingly exposing sensitive information online. All right. After that, it is very interesting that even the network services, the traditional network services, are not that uncommon. Still not that uncommon, and we feel that many of these services should not be exposed online for no reason. They should be exposed online. So what we have figured out, what we have shown from our statistics, that 80% of large organizations or organization of certain size, a significant size, has multiple exposed UAT servers. Now, why it is a problem? The problem is that UAT servers are generally used for testing, may not have that stringent security policy requirements. Like most of the time I've seen, the UAT servers have very weak passwords because they are used for testing, right? And if they are exposed online, then the risk it exposed is, number one, that it can actually host a data which may not be completely obfuscated, production-like data which may not be completely obfuscated, right? It may actually give attacker enough information so that information can be used to even attack production environments, like what framework it is using, what JavaScript framework it is using, what platform it is using, etc. Right? And then there are various other risks associated with exposing UAT servers online. Then every alternate day, or at least we have seen that WordPress and Joomla has some vulnerabilities surfaced up almost all the time. 1 month back, a few weeks back, there was a critical vulnerability in WordPress that got patched, and I hope that everyone, all the participants, have patched that critical vulnerability in their WordPress and Joomla. Then we have seen, Telnet and FTP servers exposed online. There is no reason unless you share the data, and even if the data is being shared, they should not be on non-encrypted traffic. Then open vulnerable routers. So we have seen instances where some of the organizations had unpatched vulnerable routers for their branches, for example, corporate branches, and using which we could actually enter to their routers and could even redirect the traffic. We have shown that. I mean, we have not done it, but we have shown it. We could do it. Similarly, 30% of organization has even the LDAP open, and few instances we have seen that LDAP is actually without password or with anonymous bind, so we can actually get all the internal emails of the employees. We also got an open RDP and Samba shares online. So this is also pretty scary that some of these traditional services are being exposed online. And could be part of the attacks by the attackers. So I think, thank you very much. This much for now. I'll answer some of the questions in the meantime. Okay, we have like 5 minutes. So yes, this webinar will get recorded, and probably Preeta has planned to share it at some point. All right. Okay. So there are too many questions probably. I'll do one thing. I'll answer some of the questions in this forum, and then probably we can send a response in the email, right, to all the participants. Like many of them are actually ideas. Someone has posted that how about decentralized internet will prevent breaches if implemented throughout the world. So it is like an idea which is good. Thank you. So someone has asked how can we get access to Equifax breach database, which has 140 million. I think this database was there online for a few, not this database, but part of this database, especially the credentials was there online a few months back, and I'm not sure whether it's still there, but yes, we could actually get access to it, and we have actually indexed the data. Same is the case with Zomato. All right, then I think what we'll do is we'll so some of the other questions, I think we will send a reply maybe over email. So yeah, so thank you very much for joining this, and we'll see you next time. Yeah, thank you.
I just wanted to inform that the webinar is over. You may please exit by closing from your control panel. You'll get a small questionnaire. Kindly answer that and exit the webinar. If any friend of yours from any organization wants to get a free breach risk assessment done, you can also drop us an email. And if you want one, then there will be a survey question. You can just mark as you wish. The webinar is over. You need to close it from your control panel to exit.